Sorry for stopping the previous video abruptly. Okay, so what I was talking about getting one head. Okay, now similarly, this will be the probability of getting one tail. Okay, it will be same. Now, the probability of getting at least one head. Now, what is mean by getting at least one head? Now, at least one head means what? One head is possible or two heads are also possible. Okay. Now, that is what in how many cases one head or at least one head is possible. That is in this case one head is there. In this case one head is there. Even in this at least one head is there. Two getting two heads is totally fine, no? So this case will also be considered in that. So again 1 2 and 3, that is three favorable outcomes divided by the total number of outcomes, that is 4. Now similarly probability of getting at most one head. Now at most one head is means what? Either zero heads or one head is allowed. Okay, not more than that. Now again in this case the total number of outcomes will be 4 as it is, and now at most one head, that is what? Either one head or less than that. Less than that means what? Zero heads, that is what? Both tails. So this one and this one are allowed. Okay, so that is basically three favorable outcomes. So again the probability of this is okay. Now let us see some basic properties. The first one is about the addition theorem of probability, which is most probably used here. Okay, now probability of getting union B is given by probability of A plus probability of B minus the probability of A intersection B. Now I'll be clear with these things. Okay, now A and B are the events. Okay, now probability of A union B. A union B is what? Happening either A or B. So that is represented by A union B. Now, if I want to uh, write something like both A and B, then it will be my A intersection B. You have studied this A union B and A intersection B, you have studied earlier. Okay, now see, now either A or B, that is what? For example, in an experiment of throwing a die, okay, my out or my event is either getting a 3 or a 4, getting a 3 or 4. Okay, that is what? This is my A or B, that is my A union B. Now I want to calculate the probability of getting 3 or 4 on a die. That is what? Probability of A union B. Now if I apply this formula, okay, it will be like what? Probability of A is what? Probability of getting a 3 on a die plus probability of getting a 4 on a die, since this is my 4, B is my 4, minus the probability of getting 3 and 4 on a die. Okay, now let's see what is the probability of this. What is the probability of getting a 3? Now if I apply the formula of probability, by definition, number of favorable outcomes upon the total number of outcomes. What is the total favorable outcome of 3? That is only 1. Okay, and total number of outcomes are 6. Similarly for this, getting a 4 is again 1 upon 6. Now probability of getting 3 and a 4. Now see, a die is thrown only once. Okay, when it is thrown only once, you can get only one number. Either it will be 3 or a 4 or a 5 or anything, but it will be only one. So getting both these numbers together is not possible. Okay, so that is what such kind of events which are not possible, like for example sun rising from the west, it is not possible. So such kind of events are called as impossible event. Okay, and the probability of these impossible events is always zero. So therefore the probability of 3 and 4, getting a 3 and a 4, is zero in this case. Okay, in other case it can be possible if suppose two dice are thrown and all, then getting a 3 on first die and getting a 4 on another die, it is fine. Okay, that is totally fine. In that case you can calculate, you will have some value for this. Okay, but when only one die is thrown, getting two outcomes is not possible. So it is this kind of event is called as impossible event, so therefore its probability is zero. So now probability of getting 3 or a 4 is what, 1 by 6 plus 1 by 6, that comes out to be 2 by 6, that is 1 by 3. So this is the total probability of getting 3 or a 4. Okay, now we just saw that the probability of getting an impossible event is zero. Now there are some events which are sure shot. For example, sun rising from the east. This is a sure event. Okay, now getting a head or a tail when a coin is tossed, it is a sure event. You can't get anything else apart from a head or a tail. Okay, so such kind of events are called as sure events. Okay, and the probability of this is always 1. Okay, now any other events lies between impossible or sure. That is what basically your probability of any event is always lies between 0 to 1. Okay, this is the thing, this is the main thing. Okay, now there are some events which are independent events. Events in the sense, if you are throwing a die, sorry, if you are throwing two dice, die 1 and die 2. Okay, now if you want to get a 3 here and you want a 5 here, now once a die is thrown you have got 3. Okay, now you are going to throw the die second time, or you are going to throw a second die. Now it is not affected by this 3. This 3 is not affecting your result of the second die. Okay, so such events are called as independent events. That is what getting a 5 or not on this second die is not dependent on what number you have got on the first row of the die. Okay, such events are your independent events, and in such case probability of A intersection B is given by probability of A into probability of B. Okay, so I don't think you will need this part anytime of probability of independent events, but yes, this probability of A intersect A union B will be very well required. Okay, and you need to keep in mind that your probability always lies between 0 to 1. There is nothing called as negative probability. Okay, probability, if anytime you are getting any other value that is either higher than 1 or any negative value, you need to see that you are going wrong somewhere. Okay, your probability value will always lie between 0 to 1. Okay, so now if I again consider this example, getting of throwing two coins together. Okay, now two coins together. Now suppose, okay, let me just write it again. Throwing two coins, it will be something like this: head, head, tail, head, head, tail, and tail, tail. Okay, now let my x variable be something like number, or xi be number of heads. Okay, now my event e suppose is getting a head, and xi be the number of heads on that. Okay, now if I want to write, this one is my first outcome. If I'm listing out the things, okay, x1, x2, x3, x4, or something like this, or better example would be something like this. X is given by x0, x0, x1, x2. Now x0 is what? No head. Okay, x1 is what? One head. And x2 is what? Two heads. Okay, and I'm writing its frequencies now, fi's. Okay, now frequency of no head is what? No head. In how many things you have no head? Only at this point. That is occurring how many times? Once. Okay, one head. Okay, it is strictly one head, strictly equal to one head. Now at how many points it is appearing? Here and here. It's strictly one head. So what is the frequency of one head? It is 2. Okay, now what is the frequency of this? That is two heads. Two heads is only appearing once. Okay, so now if I treat this as these are my xi's and these are my fi's, what will be my summation fi? 1 plus 2 plus 1 summation fi equal to 4. Okay, now if I want to calculate the probabilities of this pi's, okay, now what is the probability of no head? We have seen that, that is 1 upon 4. Okay, probability of one head, we have seen one, this is two favorable outcomes divided by 4, that is 2 by 4. Okay, and now this no two heads is what? Again 1 by 4. That is, if I go to C, it is something like this. Probability is given by this fi divided by summation fi. Okay, this is again fi divided by summation fi. This is again fi divided by summation fi. Okay, that is what, as your frequency is increasing, your probability is also affected. Okay, so that is what your probability is dependent on your frequencies. Okay, now I had given an example of something called as normal distribution. Okay, normal distribution, in that something like this bell shaped curve I have shown. Okay, and in that case I had told that at this point, at the peak, this is the middle part of this, and at these points the frequency is the highest. This is the frequency versus xi curve I had shown. Okay, now if I go to C, at these points, the frequency is the highest in this case. Okay, and at these end points, or the what we call it as the tail points, the frequency of the xi values is the lowest. Okay, now since here we have seen, as the probability, sorry, as the frequency increases, the probability also increases, or that is what, they are interdependent kind of. Okay, so if I see this, if I want to plot a graph of probability versus this x's, then it will be a similar curve. Okay, that is what, in the in between values, the probability will be higher. As the frequency is getting higher, the probability will be higher. So this is kind of probability or frequency curve. So at the end points, it will be the as the frequency is decreasing, again the probability will be decreasing. So my this is called as probability distribution, or the normal probability distribution. Or in other words, if you want to see, say I had given an example of the height of a person. Okay, and if I had given a example that is 5 feet, and this is between 6 feet, most of the human beings we see around lie between this area. Okay, that is the frequency of getting finding a person between 5 feet and 6 feet is higher. Anything taller than that is quite lower frequency, we can say. And anyone shorter than 5 feet we can see quite rarely, that is they have much more lower frequency. That is what, the probability of finding a person lying between the height 5 feet and the 6 feet is much more higher, and the probability of getting a person or finding a person taller than 6 feet is quite lower, or shorter than this 5 feet is quite lower. Okay, so this kind of probability distribution, this frequency distribution is similar to this probability distribution, and this is called as normal distribution. Okay, so this is basically a type of probability distribution which we see. Okay, so basically we are now slowly from the concept of probability we are coming back to the probability distribution stuff. Okay, which is my original topic. So probability distribution, now I had told you there are three kinds of probability distribution. One is binomial distribution, second is Poisson distribution, and third is normal distribution. Now, as the name suggests, this normal distribution is quite normal, which normal distribution which appears in the nature, which I showed just now. This is kind of normal distribution. That is, the middle values are, you can see the higher probability and a very low probability at the two tail values. Okay, so this is kind of normal distribution. Okay, so this part is quite clear. Now, only thing is about solving the problems on this. But before that, let's see in brief what this binomial distribution and Poisson distribution are. Okay, now binomial distribution. Now, this binomial means what? From the name itself suggests there are only two possibilities. Okay, now two possibilities in the sense getting either a success or a failure. Okay, now it's about binomial. That is what? Getting a success or a failure. Okay, now success or a failure. That means what? Now, if my event is getting a 3, now getting a 3 on a die. Okay, now if you're getting a 3 on a die, if you're actually getting a 3 on a die, it is a success. Now, if you are not getting a 3 on a die, that is what? If you are getting any other number, that is 1, 2, 4, 5, or 6 on a die, it is a failure. Okay, so in this case, success is getting a 3 and failure is not getting a 3. Okay, similarly, if the my event is getting ahead, getting ahead on a coin, okay, then success is what? Getting ahead, and what is the failure? Failure is not getting ahead. That is what? Failure in this case is what? Getting a tail. Okay, so there are basically only two events in this, or two outcomes, that is either success or a failure. Okay, so such kind of since there are only two things, it is called as binomial distribution. Okay, now about the Poisson distribution, this is even called as exponential distribution. Now this exponential distribution, why? It is quite an exponential curve. Okay, so you need not go into the theory of this much into details. We will be only solving the problems. Okay,